So I'm going to talk about making models, and we'll get a little bit more practice at defining variables from this and that kind of stuff. But there's several models that I want to talk about today, and they're mostly in section 2.2 in your book. We're going to talk about one or two from section 2.3. So they're basically going to be percent, ratios, markup, and I'm also going to define margin at the same time as markup. And discount. The very first word problem example I gave you was a discount problem, so we'll kind of revisit that for completeness. And then on Friday, we're going to talk about some word problems that tend to be a little bit more difficult. The mixture problem, that's like if you have something with, let's say, a solution that's 10% acid in water and another solution that's 20% acid in water, and you mix 1 gallon with 2 gallons of the other solution, what's the ultimate concentration you get? So that's what I mean by a mixture problem. Those things have a very definite form that you want to learn. Distance and rate problems come up all the time. So there's a few different models for that. The difficulty of those is when you're trying to take average speeds and make an overall average speed. And then we have something called a work rate problem. And a work rate problem is a case where, let's say, you and I were mowing a lawn, and it took us 45 minutes to do it, and you're working twice as fast as I am. Okay, so then how long would it take us individually to do that problem? And this will be the first time that we're actually going to be making equations where the variable will be in the denominator of a ratio. Up until then, everything, all the unknowns are going to be either, standalone integers or in the numerator of a ratio. So we'll get to that on Friday, but for now we're going to deal with percent, ratios, markup, and discount. So let's look at percent. Okay, we talk about percent usually in an environment where something's changing, right? Or something is a component of another. So let's say we're going to have 80 something, it doesn't matter what, change to 100, and then we're going to have 100 changing to 80. Now this is the same change, right? It either goes up or goes down by 20. But if we talk about the percent change, now it becomes a slightly different question, because if we look at going from 80 to 100, okay, we're adding on 20 to 80, so the percentage of 80 is going to be 20 divided by 80, which is 1/4 or 0.25. We have a 25% change. So we would say that 80 increases by 25% to get to 100. Okay? I think we've all heard, statements similar to that. But if we're going to decrease from 100 to 80, now this is a little different, because we're going 20 divided by 100, which is 1/5 or 20%. So when you take 80 and you increase it by 20, you're increasing by 25%. When you're taking 100 and you decrease it by 20, you're going to be decreasing by 20%. And it's not the same. It's tempting to think of these two numbers as being the same. I increase by 25%, I decrease by 25%, you don't end up where you started. And the main reason for that is that the whole concept of percent, it's calculated using a base number. And we can think of the base number as the place that you start. Okay, so when we take a percentage on the price of an item to get to the complete price from a list price, we start from the list price and we use the percent times that list price to get up to the total price. If we're going to have a discount, we're going to take a list price and we're going to take off of that list price to get to a discounted price. So then the percent plays in with the higher number, the list price versus the discounted price. And so the tricky part about percents then is to identify not only the percent properly, but what's the base number? What does it refer to? So if we look at the general model for problems involving percent, we have this compared number equals the percent times the base number. Now, anytime I talk about percent in an equation, I'm going to be really referring to the decimal equivalent of that. It's pretty uncommon to deal with the percent sign in there. You always want to change it to, the parts of 100, or make it into 0.30 instead of 30%. So that's what I mean by decimal form there. So that's the general model. So you might see these as stated as something like this, where 20 is 25% of 80. So the compared number in this context is 20. The percent is 25, and the 80 is the base number. Similar statement, 125 is 50% of 250. Now if you flip that around, you take 2 times 125 and you get 250. So we can also say that 250 is 200% of 125. And you see how we have a different number there. We either have 50% or 200%, because those are widely different numbers. Okay, so then here's a couple for you to try. What number is 8% of 60? Okay, so let's unpack this a little bit. I'll walk you through a little bit of this one. The word of is one of those key words that I talked about last week when we're talking about numbers that have their meaning as a certain mathematical operation. Like if we say something like 3 and 4, the and is the mathematical word for, or the mathematical equivalent would be plus. 3 plus 4, right, if we're saying 3 and 4. When we say of, that's always a multiplication. So think of it this way. If you go into a grocery store, you go up to the refrigerator where they're selling eggs, and eggs come a dozen per carton, and you say, I'm going to take 3 of those eggs, you're going to get 36 eggs, or 3 dozen, right? So the of is, I'm going to take 3 of that set, if you will. Same thing with this. I'm going to take 8% of 60, so there's your multiplication. It's going to be 8% times 60. Okay, I'll let you do the calculation there. Anybody get the calculation? Yes?
Is it 4.8?
4.8. Great. Okay. So we have 0.08 times 60 equals 4.8. Now sometimes the decimals are a little hard to deal with, and so if you can kind of take the shortcut to this thing, saying that 8% is a little less than 10%, right? So 10% of 60 is easy, that's 6. So if you just take 8 times 6, that's 48, but you want a number with a decimal in it that's just a little bit less than 6, then you say, okay, that's 4.8. So you're kind of estimating your answer, doing the computation with the numbers, and then locating the decimal place depending on your estimate. So that's kind of a handy thing, a handy way to look at doing these things without counting all your zeros and decimal places for each time you do a multiplication. Okay, so here's a little different arrangement. 42 is what percent of 70? How do you do that? How you doing? Okay. Okay, I see a few of you have it, a few of you have restarted, you must have thought of something. And we'll go on here. So this is the thought. Okay, so we look at this model, the compared number is 42 equals the percent. Now the percent is the unknown value, so I'm just going to use P for the percent, and then 70 is the base number, right? Percent of the base number. So we solve for P by dividing both sides by 70, and we get 3/5, reduce the fraction, and 3/5 then is 60%, right there. Okay? So once you reduce the fraction to something like 3/5, now you can do the long division, or the other way that you can do this is make the denominator 100. So if you look at the numerator and the denominator times 20 will give you 100. So you multiply 3 times 20 and you get your percent of 60. Okay, so you can avoid doing some long division just by manipulating your fractions. Okay, and the last one is 36 is 30% of what number? Okay, anybody got an answer? How did you do? You got an answer?
I got 120.
120? Okay, good answer. Anybody agree with that or vehemently disagree with that? Yes.
Oh, no, I agree.
Okay, that was a hand of agreement then. Okay. All right, so we set this one up the same way with the model in mind. 36 is the compared number. 0.3 is the 30%, the percent in decimal form. N is your base number, so you divide both sides by 0.3, multiply the numerator and the denominator by 10, and we have 360 over 3, which is 120, and we got the correct answer then. All right, let's move on to ratios now. Ratios are another word that you use in relation to ratios is a proportion. And so when things are done proportionately, that means that there's some ratio, A over B equals C over D, that this ratio stays the same. Okay, so if you have, the ratio is, let's say you're baking a cake, that you put in 1 egg per cup of milk, then you have 1 over 1. So if you're going to use 3 eggs, you know you have to have 3 cups of milk. You know, that kind of proportionality. And so when we have this, the way you set this up is that with your verbal model, you arrive at this kind of proportional statement, but then when you try and solve it, you either multiply one side or the other by the denominator, or you could even use the reciprocal if you want to set up the ratio. It's equally valid if we say B over A equals D over C. And so these are 3 forms that can help you actually calculate that. So the key is, don't worry about the multiplication and division initially. What you want to do is you want to take that ratio and then think, okay, how do I solve the ratio? And so probably a good start with this kind of proportionality is think about two similar triangles. Now what makes a triangle similar to another is that all the angles are the same and that the sides are in proportion to each other. Now you have an opportunity to define these ratios any way you want. There's no single correct way. You can say, okay, 4/3, the height times the base of the first one is the height times the base of the second one, 8/6. Or you can say the hypotenuse over 3 is the same thing as 10, the hypotenuse of the red triangle, over 6. Or you can take the other two sides, and 5/4 is 10/8. And like I said earlier, you can also, if it's going to set up your problem a little easier, you can use the reciprocals. 3/4 is equal to 6/8, those kinds of proportions. Okay, so here's one for you to try then. If you have two similar triangles, that means their angles are the same and that everything's in proportion. What's the missing side here? How would you do that? So set up the proportion and then solve that. So if you look at the other ones, you say, okay, I can take two sides and make a ratio and have a third on the other triangle, have a ratio that should be the same thing. And so when we set up the ratio, you want, maybe 3/8 equals your unknown divided by 12. So I'm going to make that unknown x. And so I have x/12 equals 3/8. And so I can multiply both sides by 12, and I get 36/8, which is 9/2. Now you could have gotten 4.5, right? That's probably the thing that if you're actually doing the long division or something, you'll get 4.5. It's an algebra class here, so I'd like you to keep it in integer ratios, all right? 4.5 would be the right answer, but for algebra, reduced improper fractions is what we're going to go for. Yes, Melissa?
Why did you decide to make it like 3/8 instead of 8/3?
You could do that.
Okay, because I did it like opposite, but I got
And you got the right answer, right? Sure.
Actually, no, yeah, I got some answers. Yeah, I would know.
Yeah, the proportional ratios work, there's nothing magical about being the numerator or the denominator. So this is what you did, right? 8/3 equals 12 over whatever variable you used, x. So it's just a little bit more work to solve that than it is when the x is in the numerator, right? Because you want to make this one cross multiply. 8x equals 3 times 12, and then x equals 3 times 12 divided by 8, which is the same calculation that I did. Yes?
Can you not set it up like 8/12 equals 3/x?
Yeah, that works as well. Yeah. So the proportionality that you're stating then is that one side is to its corresponding side as another side is to its corresponding side. So what you're, that's a fancy way of saying, I think what you're getting at, where you said 12/8 equals x/3. So the proportionality comes from comparing the two sides and then making a similar comparison with the side that you don't know. So then here again we have 12 times 3/8 equals x. There's almost no way wrong to set this up, so long as you're making the correspondence, like if this is the we'll call that, for the lack of a better word, the hypotenuse to the hypotenuse is the same ratio as the height to the height. And here I'm stating the ratio is the two sides have the same proportionality. So I take 8, which is that hypotenuse, divided by 3, same thing as 12 divided by x. So long as you're making a one-for-one correspondence, it's difficult to go wrong. You can make your ratios work almost anyway. Okay? Now let's take something that's perhaps something that you would relatively easily do in your head, but just to show how this works out as a proportionality and not just a real quick calculation. Let's say I want to paint something, and I go into Home Depot and I look at a can of paint that says that that can will cover 400 square feet. Now, if I know what I need to do is paint 2,800 square feet, how much paint do I need? So we think, okay, we would normally take 2,800 divided by 400 and we get 7. And what we're thinking of is the proportion. So we have the ratio of the area to the gallons is constant. Okay, so 1 gallon doesn't cover more than the other. So what I'm going to say then is if 1 gallon covers 400 square feet, G is the number of gallons I need. I'm going to say 400 is to 1 as 2,800 is to G, the number of gallons. And so by solving for that G, what I get is 2,800 times 1 divided by 400 is 7. So I need 7 gallons of paint. Now this was convenient because I knew the rate for 1 gallon. But let's say I'm looking at, instead of a gallon, I'm looking at a quarter of a gallon. Let's say it comes in, smaller cans. And so how much do I need? So instead of saying 400 to 1, I'll say whatever it is, 100 to 1/4, or whatever the coverage is for that particular can, because that will then stay the same, and we can use that ratio in whatever context. Or let's say if you want to buy it in bulk, if you have, you look at a 5-gallon pail, and the 5-gallon pail will say, well, it covers 2,000 square feet, then you would do the 2,000 divided by 5 equals 2,800 divided by G, and you get the same answer. Now what I'd like to do is talk about markup. And markup here, in this context, means I'm going to take a cost, I'm going to mark it up, and that's going to be my price. So if you're in business at all, you're buying and reselling things, and you put a mark on it, a markup on it, to get to the selling price. Now, that markup is generally guided by a policy that you have. Like, if you're selling many different things, you want to keep your markup fairly consistent. So you might decide that, well, in order to be profitable, I need to have this sort of a markup. And it's normally in a rate. And so you would have one of these two-part kind of models again, where your markup is your markup rate times your cost. The important thing here is that markup is always considering cost, because when you're marking it up, what you're marking up is the cost, and you're arriving at the price. So then cost is the base, and so you buy it, you mark it up, and that determines the price. And let me make a correction here. This should say not cost, it should say price. Okay, so here's an example. So Bill has a booth at the farmer's market, and so he's going to buy bananas, and he's decided he needs to mark them up by 20%. So what is he going to sell his bananas for? Well, let's apply that to our model. And so 15 cents is the cost of the banana, 20 cents is the markup rate, and so we can get the markup directly from this. We take 15 cents times 20%, and so we get a markup of 3%, or of 3 cents, and so you add the 3 cents to the 15 cents, and the price then that he sells his bananas for, 18 cents a banana. Okay, so with markup, it's a decision on what are you going to sell things for. You take your percentage of markup, apply it to your cost, and you're good to go. Okay, so you try this one then. So you're talking to a shoe store. You find that they mark up their shoes 50%, and if it buys a shoe from its supplier at $65 per pair, what's the store's price? Now, I'm not showing you the model, but perhaps you can retain it, or maybe you should. Well, you should have it in your notes. So let's see how to calculate this. All right, so we know that the price is the cost plus the markup. The markup is the markup rate times the cost. And so I'm going to say P is my price. $65 is my cost. My markup rate is 0.5. So my markup is 0.5 times 65. And so I take my $32.50 and add it to the 65, and I get $97.50. Okay, any questions on that? All right, now I'm going to talk about something that's not in the book, but I think margin goes hand in hand with markup. And so if you look at the first line of this model, it looks like it's almost identical to the one that we had for markup, right? We took a cost and we added a markup to get to the price. But now I've substituted the word margin. And what I mean by margin now is that the margin will have a rate, a percent, just like the markup will, but we're going to use it compared to price. And so generally when you're analyzing a business, you look at either the revenue or the price, how much money you're getting in, and then say, what is my margin? So just like in that early example when we went from 80 to 100, that was the increase was the markup. From 100 down to 80, not that I'm decreasing anything, but I'm measuring that value in terms of a percent, that's my margin. So here's a little scenario, and I'm using price, and I'm going to use revenue interchangeably with that, because that's just the money that you take in from your sales, okay? So if a month's sales were $50,000, and the accountant says he had a 20% margin, what were his costs? And so this is really the question that goes hand in hand with margin. I know what I took in, I know what my margin is, what is my cost? And so we apply this to our margin. We say, okay, we don't know the cost, so C is the cost, 20% is the margin rate, the sales is $50,000. And so our margin is $10,000. And so if we have C plus $10,000, so his cost was $40,000. I know that kind of scrolls by a little fast with the calculation. But here the key feature is that we're taking the revenue, which is based on price, and taking a percentage of that to figure out what the cost is. And so the difference here is that we're talking about the same value. The margin and the markup in terms of dollars is exactly the same, but the percent is different because it has a different base. I see you frantically writing, some of you, so I'll try not to go too fast here. And this will be posted this afternoon, so if you want to go back. Okay? So let's compare the two. I've already made some comparison, but we look at markup is how much do you add to the price, or to the cost, I mean, to establish price. And the margin then, contrast that, is the margin is how much did you exceed your costs with respect to the price. Okay, so we look at markup percent uses the cost as a basis, and margin percent uses the price as a base. So let me make a little graph. So here we have, let's say, what something costs and what the price is in a business. So we have the price, hopefully always you're selling at a higher price than your cost, right? So you have this cost and this price. If that price is 100 and the cost is 80, the difference between the price and the cost is 20. Now, oftentimes they call that your profit, and it's not really your profit because you have other things to pay. You have your salaries, your rent, all this kind of the fixed costs, if you will, that's taken out of that as well. But when we talk about margin here, the margin is a 20% margin. The markup is with respect to the cost, so that's a 20%, 25% markup. And so those percentages aren't the same. So if we had a 25% markup and the 25% margin, there's no solution to that. Okay, so here's one for you to try, a calculation. So a store sells watches, sells a watch for $400. Let's say it costs the store $240. What is the margin and what is the markup? Rates I'm talking about. Take a look at a solution here. Okay, so what's the solution here? All right, the margin and the markup in terms of dollars is exactly the same. It's 400 minus 240 is $160 margin or markup. This is a fixed number, okay? So we look at a rate. So the margin rate is the margin divided by the price, and so we get a 40% margin. So for markup now, we take the $160 and divide it by the cost, and so we get a much different ratio. Now, just to kind of talk through how you divide 160 over 240, you can already reduce that pretty readily to 16 over 240. But just to illustrate how I do this, and I think it's a fairly efficient way, because I just don't like long division, is you factor it. Okay, 16 times 10 is 2 times 2 times 2 times 2, which is 16, times 2 times 5, which is 10. A similar breakdown with 240, that's 2 times 2 times 3 times 2 is 24, and then 2 times 5 is 10. So you get all those, and then you go ahead and cancel those out, and you get 2/3, which is 66.7%. Now, what I said earlier about integer ratios and answers, that applies to just about everything except percent. You simply don't want to put percent in any kind of a fraction. It does make sense to say 2/3%, but that's different than 66% because 2/3% is less than 1%. So to avoid any kind of confusion, write it as a number. In this case, 2/3 is 66.7%. All right, so we'll revisit this discount thing. I've talked about the discount, and just to kind of put it in the context of the other models that we looked at, we have the list price minus the discount is the discounted price, and the discount is the discount rate times the list price. All right, so here's one for you to think about. So Sue bought a book for $12 off of a table that said 25% off. And the $12 was the discounted price. So what was the book's original price? I think we only have 2 minutes to do this, so I'll let you think about this and maybe jot a note or two, and then we'll cover the answer here. Okay, so this is applying the model now. What would be your variable? It's the original price, right? So that's the list price. So I would say P is the list price, 0.25P is the discount, P minus 0.25P equals the discounted price, which we know is $12, so we end up with the equation P minus 0.25P equals 12, and 0.75P, when we combine like terms, is going to be 12, and so we get P equals 12 over 0.75. Now, I ran out of a little room on this, so I spilled over to the next slide. And as soon as I talk about this, I'll flip back so you can complete your notes. But one of the ways that you can do this is make the 0.75 into 3/4, into a fraction. And so when you're dividing by a fraction, you're actually multiplying by its reciprocal. And if you're not following that, we do have a unit where we're going to do this a little bit more. But here, what I have is 12 times 4 divided by 3, and if I factor my 12, my 3's cancel, and I get 16. So there's not a whole lot of computation there. I mean, you can take 0.75 and divide 12, but that would take you a little bit longer than just taking advantage of these integer ratios. So the answer is 16. And that makes sense. If you have 16 that you're going to take off a fourth of the price, a fourth of 16 is $4, 12 minus, or 16 minus 4 is $12, the discounted price. Okay, so I'll leave that up there if you want to complete your notes. I see a couple of you are. And then your homework can be in the front table here.
I have a question from the online webwork. I tried to write those two, like, using the symbols, and I tried one time, and I couldn't figure it out.
Okay, let me see what you did myself.
Okay, I tried a bunch of different things.
Yeah, don't worry about it.
Okay,
I will answer you on that, okay?
thank you.
On the whiteboard, are we graded on the first because it's kind of show?
No, I'm giving you a bunch of examples. It's unrestricted and it's not. So in the normal course of things, when you're doing a problem set, you get something wrong. I know sometimes you just make entry errors or you don't put the right parentheses.
Yeah, and then like on the whiteboard, does it just submit by itself? Like you can see, you don't have to.
Once you
Do the problem, it just submits. Alright, thank you.
That was my question.
Yeah, you do have to, every question has a
Yeah, it's the answer.
But once you're
After
there,
that, it's.
you're done.
Yeah, because it moved on to like page number 2 or section number 2 on its own now. Is this in? Did I officially do this? I hope so. Anyway, thank you.
Good.
Thank you.
Are you
Okay.
able to help me out with number 4?
Sure.
I have the question right here if we need to look at it. It's that one.
Oh, it's on here. Let me put on my glasses. Far too small for me to see. So is this a 5, the iPhone?
No,
Or is
it's
it a
the
4?
4. I still haven't gotten the 5.
Yeah, I'm thinking about replacing my phone. I have a, okay, but you need 4, right?
Yes.
Okay, the perimeter of the NBA basketball court.
Mhm.
Okay, so what we have is 288,
Mhm.
and we know that we have a width, and that the length here is going to be 44 more than the width.
Mhm.
Okay? Okay, so let's look at what the perimeter is. So our perimeter is going to be the sum of all the sides. So if I just write it out without any multiplication, I get this. All right?
Yeah, so far I have, I did 288 is equal to 2 times by L plus 44 plus 2W.
Yeah, okay, so we have 2W plus 2L, like this,
Mhm.
right? And then what we do here is we take advantage of this, that L equals 44 plus W.
Uh-huh.
And so we have 288 equals 2W plus 2 times
Right,
44 plus W. That's where you got it.
yeah.
Okay, so now what we do is we just expand and simplify.
Mhm.
288 equals 2W plus 2 times 44 is 88.
Right,
2 times W is 2W. And so we have 288 equals 4W plus 88.
oh, I think that's where,
Combined terms, that's all you have to do.
I think I forgot to, wait, what did I do? I think that's where, I'm trying to think of what I did. Cause somehow I got 200 is equal to 2L plus 2W.
Yeah, you need to eliminate, you probably put in your L right here, right?
Yeah.
Yeah, it's W, right? Because L is 44 plus W.
Oh, okay.
All right, so once you do that, then it solves for you. Then you have
Okay.
200 equals 4W, W equals 50.
Oh, okay, got it.
Okay, I'm gonna shut this thing down. Let's do this.
Thank you.
You're welcome. Tell me your name.
Nicole.
Nicole. Okay, I'm still trying to get everybody's name down.
Yeah.
so.